So welcome everybody. Thanks for your time for attending this session. I am Rajesh Vasareddy. I'm from the CSEO group within Microsoft. Core Service Engineering Operations. What we do is we engineer, build, and operate applications and infrastructure for all business units within Microsoft. The traditional finance, sales, marketing, all business internal units leverage our infrastructure and the application portfolio that we engineer for their day-to-day operations. So what we're going to talk here today is we had a large data platform footprint, just like any other enterprise out there, backed over ages in our data centers. And as a part of this cloud journey, we had a great transformation story. So we felt that there's enough value in bringing our experiences to the audience here out there to see some of these experiences may help you think about how you're going to move your data platform to the cloud and what are the things that that you may be benefit from looking into this content. So my primary focus is on providing hands-on consulting for moving legacy data platform solutions from on-premises to Azure, lift and shift, and modernizing into PaaS as well. So let's break the ground with, this is a true one-slider of how our landscape used to be on the left-hand portion colored slide on how it is right now, which is still we consider as an intermediate hop. We're not there yet 100%, but this is where we are. All the business units relied on this application as a one source of technology stack. SQL Server instances power almost our entire stack for ages. Naturally, being our in-house product, it served all our needs so far. We never had the need to go out beyond the SQL Server stack. However, with the cloud journey, we still have a handful of SQL Server instances running on IaaS virtual machines. There are many applications that doesn't have a lifespan or not have engineering investments or have a legacy code. We lifted and shifted to IaaS VMs with SQL Server instances. So that's kind of rehosting it. And there are a bunch of applications that we re-architect them to fit into some of the past technologies where SQL DB, DW, and Cosmos DB. And there are a very handful of applications that are rebuilt all the way from scratch without completely off of Microsoft stack technologies on leveraging streaming data, Spark, HD Insight, and blob storage. So when we think about moving our application portfolio to cloud, we know that the front end, the middle tier, will be the most easiest to go because the VMs are going to be exactly the same and actually way more powerful than our on-premises on Azure. It is the data platform that always have heavily funded physical devices, infrastructure like SANs and Fusion IO cards, all the flash cards supporting the IO power required for the data platform technologies, which seems to be a little different from what we can get in any public cloud. So the storage architecture in Azure going to be slightly different. So it's going to be the bottleneck for most of the applications to see if it's going to be successful when we migrate these data platform instances to Azure as it is. So we kind of went through a three-phase process. We assess, we migrate, and we optimize the whole data platform. In the first part of assessment, we carried over like how many instances? Thousands of instances. We look at the inventory of the total footprint today we have in our on-premises data centers. We feel like there are hundreds of instances where we don't have any ownership. We don't know which application to work for. They are accumulated over a period of time. Being in Microsoft, we have the privilege to even a contingent staff member can pull up a server, grab a copy of enterprise license, put it on it, and just do a 30-day POC and leave it there. And we never got a chance to revisit some of that. So we took this time to go through the list of the inventory, the footprint we have, and we figured out that almost 20 to 25% of the such instances are lying out there with no business process associated with. So there's no incentive for us to clean for moving as it is the baggage we accumulate over a period of time. So we started looking like, okay, putting a banner screen there for 30 days saying, hey, if somebody care about, please talk to us. No response. 30 days down the line, we started snoozing the servers so that we still gonna be checking if there is any leftover people who are still using this instance. And 60 days, no response, we decommissioned them. So right off 20-25% of the footprint, way in, we got rid of from this migration plan. And the second step, these applications that have these infrastructure instances sitting there. And when we look at each application, have 5, 6 environments like production, UAT, dev, perf test, whatnot. Every team in their own due course of engineering, development, and testing, performance testing, auditing, they created their own setup of instances, which are just like the production instances. Agreed that in the world of on-premises, it is hard for anybody to procure resources on demand. So what they did was they just gathered those instances, withheld them, and use it once in a quarter, just provision and test it and leave it there. So with the cloud, we got a new possibilities that our ability to provision and dynamically provision and scale on whenever we need. We don't see a need to carry all these environments. So we rationalize the number of environments each of these application had into just basically 2 categories, production and non-production. So any application moved to cloud have just these 2 flavors of environments out there. And if somebody needs, say, an ad hoc environment, they can just leverage the existing copy of non-production and then spin up a new VM, solve the purpose, and then decom the VM. So another 30% of our footprint gone. So we were left with not more than 55 to 60% of the total inventory be considered even for to move to the cloud, and still business is happy with that. Because the rest of the 30-40% is a true overhead that we carried, that like any other enterprise carried over the ages, because the Dataable platform is segregated, no single owner for that. Tons of applications got sunset, and but we still have assets out there in the data centers. And number 2, when we have these instances that we pick finally for, these are the things that are going to the cloud, we then started rationalizing, okay, how many of these applications are on a sunset path or very legacy that have no engineering resources, that who worked on the code base is still there, and we have no incentive to invest any more engineering effort. We simply consider them for lift and shift to Azure. So there's no code changes. It is merely a brand new data center called Azure. We got the same VMs and move the footprint as it is with no engineering effort. So it's simply a cutover, just like you got a new set of boxes after your end-of-life hardware. You migrate them into the new instances. We did this exactly the same thing. But there are a handful of applications where we know that have a reasonable engineering investments, have a considerable lifespan. We invested our efforts in re-architecting them to factor into the past solutions, be it SQL database or data warehouse. It opened up a new avenues for us in terms of unmatched amount of scalability, resiliency, and the total cost of ownership reduced. We no longer care about installing, patching, and all that stuff. So we know that's the ideal state, going to be moving as much of our applications to PaaS. So we moved them. And as I said, there are a few of applications that we believe, like finance, payroll, HR systems, that's going to exist till the company going to exist. So instead of spending time on trying to fit the existing model into a PaaS, we started rebuilding it from scratch, moving away from the traditional batch processing kind of monolithic application model to distributed streaming data, smaller chunks of data, using non-native Microsoft Stack technologies, Spark, HD Insight, blob storage. So we went through that exercise, but it took a long amount of time and engineering effort to achieve even to the state. And ultimately, the third phase is, we know we just move this application, but end of the day, it's going to be a different environment and going to cause a different experience to the end customers. So we tried our best in terms of mitigating the potential impacts the way in, but still there are things that we need to do post-migration. So we optimize the performance and the costs also as a third aspect of removing this cloud. So we're going to talk about a few minutes on the most important aspect of our migration. As we discussed, there's 3 aspects that we just consider. Gartner says there are a couple of other, but we fundamentally want to bring these 3 broad categories. Lift and shift. These are dead applications. Like, we have no engineering investments, and these are on a sunset path. We just pick them as it is and move them to Azure. And we are aware of that. Azure offers a broad set of SKUs that helps us to figure out we don't need the large instances that they have in an on-premises. So we did our fundamental analysis of how much computing power and the storage power it needs, and we picked the right SKUs the way in. And in the post-optimization phase, we adjusted the SKU accordingly. In the re-architect phase, it took a reasonable amount of time. There are feature gaps in the initial days of PaaS technologies, being SQL DB or DW or any other technologies. There's a huge feature gaps between the box product versus this PaaS offerings of the SQL Server. However, we kind of felt that we are in a close lock with the product group. We know where they are going. Product group is no longer delivering things once for every 3 years. Rather, they're releasing features every quarter, in fact, twice a quarter. And we started our journey, okay, let's not wait until we get the great, entire feature compatibility set. We started picking the applications by assessing, okay, you are using these 10 features that are legacy that we need. So we started calculating the blocker list. And the least blocker list are considered first to move to the PaaS, and we re-architect them to the PaaS. That helped us over a period of time. The feature gaps reduced, and the blocker list reduced, and naturally being eligible to port into the PaaS. And rebuilding is a long process, and as I said, it completely redefined how we thought about data processing back in those days to the new technology stack beyond Microsoft in this new world. Virtual machines. This is considered to be the most easy aspect. Because there's no code changes required, we're moving the systems as it is to Azure. However, if you're a traditional DBA who concerns about the performance of it, we know that almost 60 to 70% of the infrastructure cost for supporting any data platform is invested on giving like solid I/O power in terms of storage, SAN, and the Fusion I/O cards. In Azure, your IaaS VMs, we have better compute and memory, and the storage performance is going to be definitely different from what you have in on-premises. It is not directly attached storage. It's going to be remote storage. Yes, it is premium storage, but it is still not direct attached storage. And the compute, IaaS VM SKUs, we just pick the SKU based upon the number of cores in VM, but we often tend to ignore the fact that every compute SKU in Azure comes with an I/O throughput allowance. So a D14, let's assume, can only do a maximum of 750 megabytes per second. That's it. No matter how many individual P30 disks you pull it together, if you have 10 P30 disks and each disk is capable of giving 200 MB per second throughput, you stripe it together, you're expecting the 2 gigabytes per second throughput, but your compute have a hard throttling layer of 750 MB per second. So we need to understand that what is your I/O power that is required for your on-premises to run your application to deliver a certain job in, let's assume, in an hour. It's going to be much more different and highly likely not going to meet that bar as it is. So we have to mitigate that impact by leveraging different services at the Windows layer on striping, picking the right compute SKU, right storage, right premium storage disk, and pulling it together, and reducing our footprint also. When I say reducing our footprint, what we did is we simply called out compression as a mandate. Because we know that for data platform, SQL Server, or any instance to be successful in IaaS, storage is going to be your bottleneck. So we made a policy saying that compression should be turned on by default. If you don't, we do that compression for you. And we started running a service where we call out the number of indexes that were out there for ages, and no index has been never touched for a long time. We figured out those indexes and we dropped them. So we know that's going to be bottleneck. We try to give them as much as we can by mitigating, by using Windows storage spaces and pooling and premium storage disk. At the same time, we reduce our footprint by enabling compression and other strategies. And we never did an automated migration, even though it is a possibility. What does it mean is, we know that the performance is going to be different. We manually build the systems first, added the newly added Azure machine as a DR node for the existing on-premises systems. On a less critical day, we fail over our actual business to the Azure node and gauge the real performance to its benchmark performance on on-premises, and we quickly fail back on always on, and we kind of we know how it's going to be, and took measures to counter the negative performance. And when we reach the satisfactory state, we permanently failed over to Azure, make Azure your primary, and kept DR your on-premises for a while, and eventually it's completely on Azure. And when we went to Azure, there are some inherent possibilities that are opened up. On-premises, somebody else provisioned the machine, somebody else patches it, backup is a completely different team. We took this opportunity to redefine the ecosystem for the IaaS footprint. We leveraged Azure management fully. We made self-service backup with Azure Backup Vault. We integrated almost monitoring and patching has been made self-service. So the total cost of ownership, somebody else paid in the back in the days, but when you're giving the keys to you, it comes with some inherent responsibility as now you can manage your own set of services, but you pay for that. We took a role of, we don't do it for you, we will enable you to do it yourself. And for the PaaS, these are the applications that we know that it's going to be there for a while, and we have some reasonable engineering investments, which means we cannot afford rebuilding it from scratch because of the criticality of the systems, but we can make tweaks. As I said, some of the services that came very handy is Azure had a service called Data Migration Assistant. What it does is it connects to your existing SQL instances, run a scan on your code base, and tells you what is your ideal destination should be. So if it figure out SQL database is going to be your ideal destination, it will call out the 10 breaking changes that you need to address and fix to make them compatible to lift and shift. And there are some best practice suggestions as well. So we kind of use this to build a report on what does it take to port this application to PaaS. And DMA came as a handy tool to provide that input out to the engineering teams on these are, for every instance you're seeing, these are the number of breaking changes that you need to fix on so that they have an idea of what does it take, the quantitative effort to make them applications to survive on Azure PaaS services. With the Azure PaaS services, we all know that this is a managed service where you no longer worry about the availability of it because the systems are... Just a sec. Can you hear me now? Oh, sorry. So fundamentally with the PaaS services, we know that it's going to be, it is a managed service offering from Azure where it assures you the availability of it. The systems are inherently resilient. Your geo-replication, everything. Just imagine on on-premises days, be it SQL Server, Oracle, or anything. The thing is maintaining HA and DR. Building systems up so that they are always up and making sure the data being synced across the copies of your data. Here, you got the situation where a network flap causing faulty heartbeats, causing failovers, and being out of your replica copies being out of sync. Just imagine like 3-4 different teams working on it and pointing at each other on what's causing it. Here, Azure with a click button offers you that your database is always available. You have backups taken care. You don't need to act differently. You get intelligent insights, which is a unique offering to the PaaS services, which means it actually gauges your operational telemetry to tell you, oh, here you go. Push this button to add this index because I figured out that these are the indexes that's going to help improve your performance. So those are unique capabilities of PaaS solutions that get shipped along with the SQL DB and DW and most of other data platform technologies. And we have lesser focus on the points of failure for your business, and you can spend most of your time on making most of your data out there to improve your business performance. And we know that you still got a problem. Okay. We can hear you? Okay. So most of the SQL database queues, when we talk to the external customers, they get like, oh my God, there's a sticker shock. A P15 going to cost you $6,000. I can get a box for it. However, we were just looking at the sticker cost, the price of each of the SKU. But be mindful of the fact that when you have an IaaS VM on premises, we're talking about 2 redundant systems and somebody else paying for real estate, somebody else paying, doing patching, maintenance, and incident management support. So looking at all that total cost of ownership as a cost. I think it's gone. Yeah. Can you hear me? Oh, yeah, much better. So looking at the total cost of ownership as a unit, Azure SQL Database and other PaaS technologies, if fine-tuned to fit into an operational model, it'll be lesser expensive than the total cost when you manage an IaaS VMs with the setup of high availability distributed across the geographies. And these are the applications, the final piece of application, very few, but we still rebuild them, where we moved away from the traditional box process thinking like, oh, we don't need to accumulate all the data over a day and do a massive batch processing overnight, versus we continue to stream the data into much cheaper data stores such as blob storage and use Spark and other technologies to provide kind of a streaming and relay type of mode, where you moved away from this one big point of failure to having better outcome for your business. It took a long time, and we heavily invested on our people in improving skills. It's a huge mind shift change from the traditional SQL Server world to the non-SQL Server world. Most of the technology we used there are open source. Some of our critical financial systems, publishing the books, the pipelines, now everything moving in the direction of rebuilding completely all the way from ground up, because we don't want to port the 20 years old thinking of accumulating and rebuilding and developing things to more of a streaming data, get it better insights for your business. So some of the takeaways, as I said, is when we're looking at adopting, picking at, oh, why should I go to PaaS? Oh, because the P15 going to cost $5,000-$6,000, where I can get a VM or something for a much cheaper cost. Look at the total cost of ownership. For an enterprise back in the days, somebody else owned the cost center for all those things that you never cared about. You got the VM, you got the machine, and that's for you. You don't care about who is paying for the rest of the ecosystem changes. Whereas with Azure, it is very transparent that it comes to you by default. So when you have to build an application, lifting and shifting an IaaS, it may look like, oh, it's the cheaper VMs, but when you look at the total backup, incident support, patching, you may be offset by leveraging the PaaS services. So we had this conversation on how much amount of money we should invest on re-engineering this application to fit into PaaS versus continuing to be there on IaaS. We felt that, okay, there is a great evidence for us to invest on engineering the applications to fit into the PaaS. And migration is a well-planned activity. It's not going to happen just like that. There are some toolkits that are available from Microsoft. If you have a non-Microsoft sources, SQL Server Migration Assistant, SSMA, will help you talk to different Oracle, MySQL, and other data sources. They have a migration automation that available to port your sources into target data sources in Microsoft Data Stack technologies. And for the data platform to be successful, there's one thing that we invested heavily is on your storage going to be your bottleneck. So be prepared to mitigate in all layers, not just on the Azure side. You leverage the advancements in Windows and take the advancements in SQL Server in-memory technologies and reduce your footprint and increase as much as you can on the I/O power side. So that's going to make a lot of difference, because 95% of our applications, their performance had a significant drop just because they don't get the same level of storage performance of what they got in on-premises. It's going to be different. It have its own advantage of why the storage, Azure storage is remote, available. It lets you pick the SKUs on demand. If it is directly attached to storage, you never can change your SKU on a tip of a click. So we invested on upgrading the skill sets for a user base. We continue to evangelize more of these patterns and practices that we use in-house. We take pilot projects and showcase the world that, here you go, this is the hardware that we use, and these are the problems that we went through. This is how you can mitigate, and so you can be successful in your rest of the application migration. So do a kind of a pilot program with one of the critical data platform applications and showcase the world that rest of your ecosystem, that how they can be successful in their migration. And we learned a big story that we should move away from not just thinking SQL Server is our only source of our data platform. We had a mindset for a long time that we heavily relied on SQL Server. We don't need relational database for everything we do. For simple data staging and all other aspects, we can rely on some much cheaper data stores so that we can leverage some open source technologies that can do the job efficiently, and yes, still use the relational database at the presentation layer of it. So think broadly on the various data platform technologies out there. May not be finite to a specific technology stream, and you can benefit from it. And don't wait for an Azure service or something to be 100% perfect as of today. So we know that there are feature gaps. Product group is aggressively working on closing the feature gaps. They are actively listening to enterprise customers and covering the gaps. So we're waiting on 6 months time to start just because you got on a feature release. We might have spent all the time to redesigning our application to make it forward by the time they cover this gap. Product groups are now very good at publishing what they are working on right now so that it gives you a predictable amount of certainties so that you can invest on modernizing this application to fit into the past. So that's some of our stories. If you have any questions on data platform, especially on tuning IaaS systems or optimizing SQL post-migration, I'll be free to take any questions. I think, there's no evaluation slide. Feel free to fill the evaluation, and that'll be helpful for me. Thank you.